Okay, these notes are for compound inequalities. We started taking these on Thursday, September the 16th, and finished up Friday, September the 17th. So compound inequality basically is when you have two simple inequalities that you're putting together into one problem. And we're going to use the words and or to create these compound inequalities. There are two different types. And the graphs are different for each one. So we're going to start out with an intersection. An intersection uses the word and. Now, in a compound inequality, sometimes you'll see the word and stated. Most of the time it'll be recognized by the way the inequality is written. The inequality is written in a double form. Let me show you what that looks like. Our first example, kind of a definition example, all real numbers greater than 2 and less than 6. So our all real numbers, that'll be our x in the center, and it's going to be greater than 2, less than 6. See how that inequality goes out in two different directions? So you have to read it starting from here, going that way, starting from here, going that way. That's kind of how you have to think about it when you're reading it. Because that can be confusing for some students because, you know, this part right here, that looks like a less than symbol, but if you're reading it with respect to x, it would be x is greater than 2. So when we graph a compound inequality, we graph both dots on the same graph. We've got a 2 here and a 6 there. Because they don't have equal to signs on them, both of them will have an open circle. And our shading for the 2, since it's technically greater than, will go this direction. Our shading or our arrow for the 6 will go to the left because that's less than. And so what we see is the two shades actually meet in the middle. That's how an and compound inequality looks. The shading goes together. All right, so let's do another one similar, but this time we've got inclusion. It says all real numbers, which again would be our x, greater than or equal to 2. So that would look like that. Again, reading it from the center, going out to the left. We're not used to reading that way, so you have to make sure that you get comfortable, and we've practiced that in class, reading it in both directions. And then also, x is less than or equal to 6. Notice how both of the symbols are going in the same direction. So then to graph, the only difference with our graph this time is we've got closed circles on both numbers. Most of the students are doing pretty well with that, knowing when to use a closed and when to use an open. And then again, our shading goes in towards each other. Some of the books show literally a shaded area, that it all kind of shades in there together. So it's kind of your what you feel most comfortable with. All right, let's look at our or inequalities. Whoops, sorry, hang on a second. All right, our or inequality, that's called a union. Unions are, use the word or, and a lot of times in these problems you'll actually see the word or written in there. So it's a great differentiation for the kids. If they see the word or, they know it's a union. If they don't see a word or, then they know it's an intersection. So that's kind of a standout trait for these. And we write these separately. We don't write them compound as we did with our intersections. So all real numbers less than 2 or all real numbers greater than 6. It has to be one or the other. It can't be both. So on our graph, we've got a 2 and a 6. Both have open circles. Our 2 is going to be shaded, or our arrow goes out this way because it's less than. Our 6 goes out that way because it's greater than. So notice how and inequalities go in, kind of like I tell them, like it's like being married, like husband and wife. It's a together connection, so our shading meets in the middle, versus an or. Think about like when you have a rowboat, the paddles that you use, they're called oars. Now, of course, it's not spelled the same, but it's kind of a neat kind of mental picture to get with the oars going out on the boat, and so when we do our graph, the shades go out. It's kind of an easy way for the kids to remember. One of my students made that up one year, and I thought it was really great. And then, of course, this one, all real numbers less than or equal to 2, or all real numbers greater than or equal to 6. So again, our only difference on this graph will be closed circles. This one will shade out. Closed circle here. This one will also shade out, again because it's an or graph, and so by this time the kids really kind of get that. Ands go in, ors go out. So Looking at the next page, our examples, we're going to actually solve these. Now this one's pretty nice. This one actually has an and right in the middle. And like I said before, a lot of times they don't have the word and in there. Your graphs will look more, your equations will look more like this. All right, so I'm going to solve each of these inequalities separately. I'll just do it from where they're written. I'm going to add 10 on this one, and I will say the kids have gotten brilliant at solving equations. They're doing a great job with it. So x is greater than, let's see, negative 9 plus 10 is 1. I'll add 10 to this side as well. And I get x is less than 5. Negative 5 plus 10 is positive 5. So then to write your answer, you kind of take these two things and you meld them together. They share the x in the center. So that's all real numbers greater than 1 and less than 5, similar to what we wrote on the front side. So if I do my graphing, I've got a 1 over here, I've got a 5 over here. For each one I will have an open circle, and then again on an and I know my shading goes to the center, and you can make it a little prettier if you want to. Just putting the arrows on it is perfectly fine. Now this one is a true form and compound inequality. It's written all together. Basically what you've got, that is one of your problems, and this is the other one. It shares the center just like on the other one. Makes it a little harder to read because the kids aren't used to seeing it that way. But let me show you how that separates out. You're going to have negative 4 is less than or equal to 3n plus 5. And you're going to have 3n plus 5 is less than 11. So doing the solving for both, if I subtract 5 from both problems, and I'll just go ahead and do that simultaneously just to save some time. Those cancel. I get 3n is greater than or equal to negative 9. Notice I said greater than or equal to when I read that because I'm reading it backwards. I'm reading it from right to left. Cancels over here. We get 3n is less than 11. Whoops, sorry, not 11. Forgot to subtract. Less than 6. Then if I divide by 3 here, divide by 3 there. No symbols need to do any flipping or anything because of dividing by negatives. So I'm going to get 3 is less than, or excuse me, n is less than 2 on this side. Those cancel. I'm running out of room here. I'm going to get, let me see if I'm going to write it up here on top. Sorry guys. N is greater than or equal to negative 3. So if I take this awesome answer and this awesome answer and I marry them together just like I did that thing, I'm going to end up with negative 3 less than or equal to n less than 2. So that is my compound answer. If I have my negative 3 here, it's going to have a closed circle on it. If I have my 2 over here, it'll have an open because of the markings on the inequality. And of course it's an and. Husband and wife, peanut butter and jelly, however you have to think about it, so the shading goes to the center. Alright, last examples. Let's see what we've got here. We've got some ors, so we know that our shading is going to go out. 2 separate problems to solve. I'm going to subtract 2 on this one and get r is less than 10. Or I'm going to have minus 5 on this little guy, and r is going to be greater than 14. So I'll start with my 10 here, my 14 there. Both of them have open circles because of their inequality. It's an open circle if it's less than or greater than. It's a closed circle if they have equal to signs on them. This one will shade out, and this one will shade out. Or always goes out in opposite directions, kind of like oars on a boat. That's the only 2 shadings you can have on a compound inequality. They're either both going to go in or they're both going to go out. That's the only option. This or, minus 4. You get 4x is less than or equal to 16. When we divide by 4, x is less than or equal to 4. And then this guy we're going to add 6. So I'm going to have 3x is greater than 27. And then after dividing by 3, x is going to be greater than 9. So there is my answer with the big wonderful or right in the center. We don't write those compound like we do the other ones, like we do the ands. I've got a 4 here. I've got a 9 there. This one has an open circle shaded this way. This has closed, shaded out. And finally, let's look at a graph and write an inequality from it. This is a fantastic ability to have, to be able to go backwards with the problems and look at the graph and write the inequality. So I look at this and immediately I think peanut butter and jelly, that thing's graphed in the center, so it's an and graph. That means I'm going to have all real numbers. I see my lowest value is -9, I put it there. I see my highest value is -2, I put it here. Let's just concentrate on this. The shading is going in towards the right. I know that means greater than, so with respect to my little x, x is going to be greater than -9. If we do our little spatula method, if we kind of cheat for a minute and I write it forward, x greater than -9, I see, oh yeah, that's shaded in the right way. And then this one right here, looking at that value, it's going to the left, it's less than, so this would be our compound inequality for that. And this one is an or, I see, because it's going out. So I know I'm going to have two separate answers separated by the word or. So let's just look at this part first. I've got my x, obviously, all real numbers, and it's got a closed circle, so I know it's equal to, it's shading left, that's less than, or equal to, -3. Or I'm going to have x is, and again, closed circle, this time shaded to the right, that would be greater than or equal to 2. So there's your answer there. That is compound inequalities.